Okay, today we're doing 10.4 and I'm going to post this on YouTube. We're doing volume today. Volume measures 3D figures. The units are cubic. So perimeter was just inches, area was inches squared, volume would be cubic inches. To get any kind of rectangular solid, which is like a shoebox, you're just going to do length times width times height. Or another way to think of it with these different kinds of shapes is you get the area of the face, or the base I call it, and then you times it by the height. So like this one, the face is a trapezoid, so you're going to get the area of that face, which is a trapezoid, and you're going to do 1/2 the height times base 1 plus base 2. Okay? I think that's 21. And then to get the volume, you take that area of the face and multiply by the height. So that's going to be 84 inches cubed. Now this one, number 2 here, is a triangle. You can use Huron to get the area of that base, which is a triangle. Get that S value, add up all the sides, take half, and the S is 12. And then to get the area, you're going to take the square root, take that 12. 12 minus 9 is 3, 12 minus 6 is 6, 12 minus 9 is 3. Square root of that is like 25.5. Now, to get the volume, you take the area of that face, and then times 3. So it'd be like 76.5 inches cubed. Now here you're going to get the, number 3, you're going to get the area of the face, which is a rectangle. Okay, the rectangle is about 126 when you do 18 times 7. And then get the area of this half circle, which is pi r squared. But remember, it's a half circle, so divide by 2. And that's, I think, like 127.2, let's say. So you're going to add up that 126 and that 127. That's about 253.2. That's the area of the face. But then to get the volume, you'll take that 253 and times it by how far back it goes. So that's 6. So you're like at 1519, somewhere around there. And that's centimeters cubed. Okay? A volume of a cylinder, that's your pop can, that's your cylinder. These are all on your cheat sheet, by the way, is pi r squared times height. So here you're going to have a small one. You have a small pop can with diameter of 4. And here you've got in a height of 6. And the giant one is twice the size. So twice the size of the diameter would be 8 across. But it says it has the same height, so that has a height of 6 as well. Find the volume of each one. So the volume of this one would be pi r squared, that's 2 squared, times 6. Okay, that's going to be like 75.4. This one, pi r squared times height, gives you about 301. So, it says, which can is the better deal? It costs 3 times as much. I think this is the better deal because you get more for your money. So this would be the better deal. Okay. Then you've got a cone. That's like your upside down waffle cone. Volume of a cone is 1/3 pi r squared times height. So here you've got a cone. Height is 10. Remember, height has got to be straight. It's not the slanted one. And your radius is 8. So do 1/3 this time, times pi, r is 8, square it, and your height is 10. Just work that out, and you get 669.87, somewhere around there, meters cubed. And then let's do one conversion. When we convert to centimeters, remember to go 3 times, because it's cubed. So 1 meter, there's 100 centimeters. 3 times. Do it again. Do it again. So when you multiply that all out, it's 66987 with a bunch of zeros, 4 zeros. So it looks really long. Okay, next page. 2 more to go and we're done.
You can't do this.
Okay, keep pointing up here.
I'm sorry.
Okay, so this one is cones. You have a diameter of 30 and a height of 10. So here's diameter 30. Your height is 10. The other one, it says either you want a 10-foot diameter with the same height or the same diameter with a 10-foot greater height. So you either can have a 10-foot diameter with the same height. I'm sorry, you know what? This is spelled wrong. This was supposed to be a 10-foot greater. This is a typo. 10-foot greater diameter. So 10-foot greater diameter instead of 30 would be 40 across, okay? With the same height of 10. Or, did I think that's 10-foot greater diameter with the same height? Or the same diameter, so that would be 30. With a 10-foot greater height, so the height would be 20. Okay. 10 foot. I feel like I made a mistake. That's okay. No, that's right. That's right. Okay, so find the volume for each one. So find the volume of this cone, okay, the height of 10 and the diameter of 40. So that's going to be 1/3 pi times 20 squared times height. And then the other one would be 1/3 pi. The radius on this one would be 15 squared times the height, which would be 20. So you work both of those out. This one is 4186 feet cubed. This one over here is 4710 feet cubed. So which one holds the most? It's the one with the larger height. So that's shed 2. Shed 2 holds the larger one. Okay, next formula is a sphere. Volume of a sphere is like a basketball. This one for volume is 4/3 pi r cubed. So if your radius is 6, all you do is 4/3 pi 6 cubed. Work that out. It's about 904.8. Remember, and this one is centimeters cubed. When you convert to meters, this time the centimeters goes on bottom. Goes on, remember to go 3 times. Move it over 3 times, you get 0.0009048. And that would be meters cubed. Okay, this one you have to know, okay? The punch bowl problem. You have a half sphere, looks like this. Radius is 12, okay? In your ladle, that's like your little scooper, like this. That's also a little half sphere. This one has a radius of 3. So they want to know how many ladles can fit in that bowl. Find the volume of the bowl. So the punch bowl volume is 4/3 pi times 12 cubed. That gives you 7234.56. But remember, it's half, so divide that by 2.